Hello, let's move on to the next piece. Okay, last time we have learned how to sort an array. We know the array actually is a collection of data. It's very often we would like to find out if the array contains a specific element. How do we search an element in the array? Okay, the very basic idea is called linear search. Check here. I put here. I just found out I gave the program a target. Hey, please search this element from your array one by one. Okay, so which means if I have the n elements, I'm gonna check n times. I'm gonna check this whole array n times, right? So let's check this code. First one, I'm saying, hey, I defined an array. Here, I called the function called search. I pass the array and my target to this search. I tell the program, hey, could you search if the 8 is in the array? Okay, let's check how this search function works. This search function takes two parameters. One is the array, one is the target. And I'm gonna return either true or false. I gave a for loop. Check here, it's a for loop. I'm gonna loop through from the first element to the last element. If element equals to the target, I return true. If after I walk through the whole array, if I didn't find out this element, this target, I'm gonna return false. That's it. So which means I'm gonna loop through the whole array. The worst case, I'm saying the worst case, probably I'm gonna check all the elements in the array. Okay, the best case is, hey, if I'm trying to, suppose for this array, I'm trying to find out the target 1. So which means, hey, I just go ahead and compare the first element of the array with target, then I return the truth. So the best situation is I just run once. The worst situation is I'm gonna run n times. N is the size of the array. Okay. So this one is called a linear search. Sounds like reasonable. However, the real situation is this method is terrible. The point is, think about it, and it's very often we need to deal with the large data. The large means you may have the millions or millions numbers. If we search one by one, which means you have to do the comparison millions times. That's super expensive. Super expensive. So that's the reason it's very often people would like to use the other methods trying to make the trying to improve the speed. Okay, one basic method is called binary search. Binary search. Okay, what's the binary search? Actually, binary search, first one, we do the binary search in a sorted array. The basic requirements, the array has been sorted. Then we can do the search. Okay, the idea is we would like to search, this one is array. Is that correct? Okay, we sorted. Suppose I would like to find out the element 3. So I just go ahead to compare with the middle element. I'm using the middle element to compare with the target. Okay, I know 3 less than 9, right? So I'm gonna check this subarray with my target 3. Okay, then I'm gonna compare the middle one, 5, with my target 3. Okay, I know 3 less than 5, right? So I'm gonna compare the middle element 3. I got it. So which means each comparison, I remove half of the elements. Let's check how to write the code. First one, I define a start and end. Start and end to represent the index of the first element and the last element. Okay, if start less than end, I'm gonna do the while loop. Okay, first one, I check what's the middle index of the array. I compare the middle element with my target. If yes, we find it, I just go ahead and return true. Yeah, I got it. And however, if, okay, check here. If my target less than middle, which means I'm gonna, my target is supposed to be in the first half array, right? First half array. So I assign end equal to middle -1. I'm gonna search the target in the first half array. Okay. Else means if my target greater than the middle element, okay, my target is supposed to be in the second half of the array, right? So I put the start index as the middle +1 as a new start. So which means I'm gonna search the target in the second half of the array. This is called a binary search. And this will be much, much faster because we only compare the log to n times. Think about it, because each iteration we remove half of the array. If we have the, suppose we have the 8 elements. The first iteration I remove 4. Second iteration I remove 2. The last element I remove next one. So I only search 3 times, right? And if I have the thousands, if I have 1,000 element, I only search 10 times instead of 1,000 times. Okay, let's stop here.